Okay, I just wanted to give a quick introduction. I'm Sylvia Terziati. I'm the former liaison. I might know some of you from being the USGS liaison here for many years. Also worked at the Water Science Center here for many years, but now I'm working for the National Geospatial Program with USGS as the Hydrography Science and Application Lead. So I tend to focus more on the technical side of our new programs, but today I'm kind of going to give a high-level overview of what we're working towards, and we're calling the 3D HP, or the 3D Hydrography Program. So probably most people in this room and in the country know about quad sheets. And the quad sheets are kind of the original integration of hydrography and elevation. And they were created starting back in the 1800s and are a great representation of how streams follow contour lines and elevation, and everything is very nicely meshed together. So kind of that's our goal, is to have this type of a representation of streams and elevation in our digital products. And again, just a little bit of background for mapping with USGS. We've been creating those topo maps for 138 years. So I should probably check the map on that, but John Wesley Powell was the second director of USGS. He started the whole project, or the whole process of mapping the United States with hydrography, with contour lines, and with other important features. And that is what we have based a lot of our analysis, a lot of our work on those contours and on those stream levels. This is how we used to create catchments, our watersheds. We have, actually, if anybody needs any paper maps, we have hundreds that we're trying to get rid of in our Raleigh office. And I hate to just bring them to the dumpster, so I can't do it. But we have literally, thousands of these kinds of maps that was the basis of what we were doing. So trying to move that into the digital age. And again, one more kind of high level history here. Originally, we were doing everything by hand. Everything was very well connected, very well integrated. In the 70s, that's when we started to do the digital elevation model, which is the DEM, the elevation from contours or from other sources, and the DLGs, which were the vector line work that made up roads and streams. And that's when things started to kind of take their own paths. So now we're kind of bringing them back together. We're integrating them in our new programs. We've been doing this for a while now, but now we're really at the point where we can really start to integrate the two. And this is what we're trying to avoid. When we have elevation that is collected now at a 1 meter resolution, and we have hydrography that's still based on 1 to 24,000 scale, things like this happen where the streams are outside of channels, and things just don't match up anymore. So the 3D National Topography Model, the 3D NTM, is kind of the next generation of what USGS is striving for. So in the last couple of years, we've been focused a lot on the LiDAR side of it, the 3D side of it, and we're about 89.5%. We have to report that to Congress, so it's always very exact. But we have 89.5% of the country covered by LiDAR, 1 meter LiDAR. And we have our legacy, what is going to become our legacy hydro products, the what was called the 1 to 24,000 NHD, or the high-res NHD, and the high-res NHD plus. So those were the national baseline data sets. Now we're in that purple square in the middle, our next gen programs. So we're going to have both 3-depth next gen and 3D-HP as our new program areas that we're going to be concentrating on to eventually get to this fully integrated 3D data model, which has elevation and hydrography and other features all very well integrated at a 1 meter scale for CONUS anyway, and the islands. So just to go through 3-depth a little bit, again, historically, it was the contour lines. We had contour lines that were taken directly from the topo maps and converted into elevation data. They were rasterized, and we went from something called the 1 arc second to the 3rd arc second. And now with the LiDAR data, we have the 1 meter product. And that is the elevation was built, starting in about 2012, 2013 in North Carolina, even earlier. And this is just kind of through the years how it's kind of filled out throughout the country. So one thing to note is Alaska is still at a 5 meter scale, although a lot of Alaska is also being collected at 1 meter. But this is just showing the IFSAR. So the 3-depth next gen, or however we end up referring to it, was conceived from the 3D Nation study, and a lot of people within North Carolina and every state participated in the 3D Nation study. It was collecting needs from state, local, and federal agencies for elevation data and for bathymetric data, which is kind of a new aspect of this. And based on that, we went through a bunch of scenarios, tried to figure out, based on what people were, the needs of the different participants, how much of the needs would be met by different scenarios, and the cost benefit that would be met. And right now we're kind of in this scenario 4 area, and I'll just go through that a little bit. So the next gen 3-depth is going to be going from a QL2, which was our base specification, which is about 2 points per square meter, to a QL1, which is about 8 points per square meter of LiDAR point cloud data. It is going to include the bathymetric data. It's going to have a faster refresh time, so going from 8 years to about 4 to 5 years. And it's going to not try to just be a one product, let's get it done and then call it done. It's probably going to be something that is updated based on change assessments and needs within the country, instead of just concentrating on getting everything complete. And that's what the assess revise every 3 to 5 years is referring to. And then deliverables, there's going to be a lot more focus on how we're delivering the data, because these data sets get huge. So how we can download the data or display the data or analyze the data in the cloud as opposed to on our desktops, that's going to be a really important part of our deliverables. Also, there's something called the 3-depth ecosystem. So that's really referring to how the elevation data integrates with these other data sources like land cover or like soils or or other things that are out there. The cost is going to be a lot more, but the needs are going to be met by 80, or should meet about 80% of users' needs. Ooh, halfway through. Okay, 3D-HP. Let's just go quickly through the hydrography program. Like 3DEP, our next gen, if you want to call it, 3D-HP program came out of a requirement study where we talked to a lot of federal, state, and local folks and private sector. Came up with a focused area that we're going to shoot for, and have been working towards that now. And so it's really going from those topo maps to something that not only is a higher resolution, but is integrated with our elevation data. That is the primary focus, I'd say, of what our 3D-HP program is right now. It's the collection criteria for the hydrography is almost all based on the elevation source. So we don't require contractors to look at other data even. It's really just, let's make this match our elevation, because we got to get those things back together again. So the data model itself is based on open standards. We're basing a lot of it on the high features. We have a lot of work going on with Canada and with other federal agencies to try and make sure that the things that we're creating are also going to meet the needs of other agencies. If you look at this little schematic here, it's really not telling you a whole lot about what's in that 3D-HP core, but I just wanted to focus on what's going into that core. Right now, the things that are feeding into the 3D-HP are EDH, which is the elevation-derived hydrography projects that are going on throughout the country with primarily contractors. Those are going in, and those are going to be LiDAR source derived hydrography. And then we're also going to be feeding in the NHD high-res, kind of a one-time layer so that we have a national data set. But as we collect more data, that NHD data is going to be replaced by the EDH data. And within that 3D-HP core, that data is going to be processed and have some core data layers like catchments and Z values on every vertex, things that are really core to keeping it integrated. And then we'll have the views on the right-hand side, how we're going to get to that data. The other thing that's been really important is supporting the Internet of Water, because we know we can't collect everything, and there's a lot of data out there that people are already collecting. We've had this addressing and indexing system for a while now on our reaches. That's going to change slightly with something that's going to be introduced, which is a high features component, which is a main stem. So instead of reaches, we'll have this main stem that will be used to address to based on the location. Those main stems get stored in a repository, let's say, in the Internet of Water, so that they should be able to be cross-scale. So a main stem at a LiDAR scale is going to be the same as a main stem at NHD plus high or medium res kind of thing. So again, populating the 3D-HP data, we're going to be migrating the 24K NHD, but really the focus is to get this elevation-derived hydrography that matches the 3-depth data. To do this, we've written specifications. Those are online. We're trying to update our website so we have all the revisions, because as we're going through, of course, there's lots of places where things change as we find, as we encounter different parts of the country. So we do have a bunch of revisions already. So if you've read, I'm sure all of you have read those 2 specification documents, but you might want to go and check and see if there are revisions that are important to you. Culverts was a big revision. People do care about culverts. And this is just another aspect of the data. The representation here on the right kind of shows the way that hydrolocations are going to be used. Hydrolocations you can think of in a lot of different ways. They can be the outlet points of a catchment. They can be a gauging station. They can be all sorts of things. So those are all going to be registered within the Internet of Water and be made available for different applications. Just wanted to quickly hit on our collaboration with NISCheck. We've been working with them to make sure that states are represented. I'm going to go really fast because I'm already out of time. And then also we have, I hate to not see my name up there, but right now, these are the liaisons that are working throughout the country. Chris Cretini is the main contact now for the Carolinas. So if you have any questions, well, you can always email me, but he can help you find data, let you know status of projects, that kind of thing. So the other part of it is the data acquisition. I think a lot of people are familiar with the 3-depth BAA, which is the broad agency agreements that we have with states and other federal agencies. So we're going to be working towards getting the 3DHP BAA as well, to provide up to 50% of the cost of projects. So we're going to be looking for partners to help with that. It's coming soon. We were hoping it would be available this fiscal year. It looks like it's not going to be, through all of the paperwork and hoops that we need to go through. Just quickly, these are the places that we've already started the projects to develop the 3DHP. Alaska, we had a lot of funding through a different pot of money for Alaska, so we've really been focusing a lot on that with a 5-meter IFSAR. But we also have a number of states, and usually we try to collect an entire Huck 8 worth of data, as opposed to a county or, a smaller unit, just so that we can have the connectivity with the stream network. That's really important. And as we piece it together and replace NHD, we want to make sure that that piece that replaces the NHD makes sense within the network. And this is just kind of a schematic of what those views might look like. Hopefully we'll be able to look at it in lots of different ways and tie lots of different data to this network. And eventually the big goal is to have this national topography model, the 3D NTM, which is it's going to integrate not only hydro and elevation, but also bathymetry and groundwater and stormwater systems and things that all affect the water cycle. So that is kind of the big picture that we're hoping comes from our friend John Wesley Powell. And that's all I got. So if you have any questions, I don't know if I have time. Oh, I did do it in 20 minutes. Okay. No. There isn't, not in the 3DHP data model, and actually not in the EDH schema either, because we're trying to avoid confusion with what the product is. So we have a lot of data that is available kind of in this raw EDH format, but that's going to be converted into 3DHP data model, and that's still being developed. And we hope by the end of the fiscal year, so October 1, we should have some data. Well, the EDH, we haven't really determined. We're trying not to have to serve out lots of variations of the same data set. So 3DHP is going to be available for download kind of as a static one-year snapshot as we go forward, because we found with some of our other data, if you're doing research or something and you need to reference the data set that you were using, it got really confusing because we were constantly updating the NHD. So the way 3DHP will be distributed is annually. You'll probably be able to get, downloads and view more recent data, but every year there'll be a data set with a DOI, a digital object identifier, so that can be referenced. That doesn't really answer your question, but it's still getting there. And the other thing I didn't talk about is, North Carolina is creating its own elevation-derived hydro data set, which one of the things that we know we're going to have to do as we're developing this is have data at different levels, I guess. So it can be, we hope to be able to accept data which might be provisional because it doesn't accept or it doesn't meet all of our specifications, but it's still going to be a better product than, say, the legacy NHD that happens to be within a state. So that's something that we'll start working towards next fiscal year as well. Is we've already defined what we have for the different categories of provisional, and then we have to figure out how. Yeah.
Will this feed into the watershed boundary data set, or watershed boundaries?
Right now, we're keeping the watershed boundary data set separate because we know a lot of people use that for reporting. So what we're going to be using is the pour point for those HUC 12s primarily as catchment out hydro locations. So we'll be able to match up what is within the WBD to our catchment network around the EDH data or 3DHP data. So WBD will still be there. We hope the catchments are going to match it a lot better than they do now. Okay. All right. Thank you.